All right, chapter 4, page 57. An experiment with time. Before we start this chapter, it would be good to remind the reader of the purpose of this book as described in the introduction. We are faced here with phenomena that are difficult to explain. It will take many years before science will have even a rudimentary understanding of mental phenomena. It is common practice in science to try to make a model which describes a certain set of phenomena closely. It may be a rudimentary model at first, which will be refined later as more knowledge of the area becomes available. A successful model for any set of phenomena has to fit these phenomena in a simple and economical way. The more new tenets are required to build the model, the more cumbersome and more vulnerable it becomes. Knowledge moves in an ever-expanding upward spiral, which allows us to see from the higher turns of the spiral our previous knowledge in a broader perspective. Thus, Newton's mechanics have become a special case within Einstein's theory of relativity. So, eventually, will Einstein's theory of relativity become a special case in a science that will account for both physical and mental phenomena? New and more sensitive methods and instruments enable us to do increasingly sophisticated measurements. We can now measure magnetic fields around our heads due to the tiny electric currents in the brain. We can make highly sophisticated measurements that show that whenever there is the slightest change in any system in the body, all other systems are somehow affected. No longer can we view our body as a collection of separate organs thrown into a bag in which a specialist can fix one organ without affecting the others. As is the body, so is the society and the whole planet, the solar system, and indeed the whole cosmos. I hope to show by the time we come to the end of this book that we are part of a highly integrated system in the broadest sense of the word. However, back to our model. In it, we'll try to tie together as many diverse phenomena as possible and fit them into a compact system. The physical, objective phenomena will serve as a starting point for this model. Experiment with time. In the previous chapters, we talked about the action of the nervous system, which receives input from the environment and codes it for us in an action rest language. This action is naturally occurring in time. That is, it takes time for any of these events to happen. When we think of time, we think of clock time. Action all around the world is synchronized by clock time, starting with train schedules, worldwide plane schedules, navigation, astronomy, worldwide telecommunication, etc. These depend completely on accurate timing. The accuracy standards of timekeeping devices have been increasing rapidly due to the demands for more and more accurate timing for space communication, navigation, astronomy, etc. Rather than use mechanical clocks, we are relying nowadays on atomic clocks. This is not a clock in the usual sense, but a device that uses the very stable oscillation of the cesium atoms as a standard for timekeeping. From grandfather clocks to wrist watches, all these clocks are supposed to chop up for us the 24 hours of the day more or less reliably into hours, minutes, and seconds. Let's call this kind of time objective, since everybody's watches are supposed to cut time into slices of even thickness. However, we know from personal experience that time does not feel as passing evenly under different circumstances. When pursuing some interesting activity, time flies. While waiting in the dentist's office, it drags. When Einstein was once asked about this psychological time, he replied with a now famous observation. When you spend 2 hours with a nice girl, you think it's only a minute, but when you sit on a hot stove for a minute, you think it's 2 hours. Having thus firmly established the relativity of time, let us see then how this subjective time can be put to some use. We know from sleep studies that during dreaming periods, time dilation occurs. In other words, if, for example, a person is awakened after a very brief period of active dreaming and is asked to describe what happened in his dream, usually a long story will come out, which would have taken a much longer period of objective time to occur. We also know that under hypnosis, time dilation can take place and can easily be noticed. Studies on such mind-affecting drugs as cannabis, LSD, etc. indicate that time distortions occur. Since these materials are not unknown substances to most readers of this book, we may possibly use them as an example when listening to someone talk while under the influence of some of the mind-affecting drugs. The feeling is that the speaker is talking very slowly and that the pauses between words are extremely long. In fact, we are sure that we could easily run once around the block before the next word comes out. There is no change in the pitch of the sound of the words. That is, the words do not sound like tape-recorded speech on slow speed. Clearly, what happens is that we somehow have more subjective time and we can observe the act of speech in greater detail. Have our mental processes been sped up relative to those of the speaker, or do we simply have more time in which to observe the event? Let's try an experiment that should shed light on this dilemma. When a person has been trained by biofeedback to produce theta waves or can put himself into a deeper meditative state and at the same time is able to watch the second hand of a clock in front of him, he will be surprised to find that the second hand has come to a stop. It's a rather startling experience, and the natural reaction to it is, this is impossible. At that moment, the second hand will accelerate and resume its normal rate. However, if we can get over this reaction and watch with half-open eyes the face of the clock while all the time being in a deep meditative state, then we can keep the second hand from moving for as long as we wish. The above experiment is naturally limited to people who have especially good control over their state of consciousness. I have designed an experiment that is within easy reach of practically anybody who wants to experience this change in time, at least in a minor way. It does not require any training or any drugs. The only thing we need is a clock with a second hand or a wristwatch with a fairly large dial and an easily visible second hand. Step 1. Relax. Position the watch in front of you on a table so that it will be easily visible without any effort through half-closed eyes. Lean with your elbows on the table if you wish. Step 2. Look at the watch in a relaxed way and follow the second hand. Try to absorb and remember the rhythm at which it moves. All this has to be done quite effortlessly. Step 3. This is the crucial step in the experiment. Close your eyes and visualize yourself engaged in your most favorite activity. This visualization has to be as perfect as possible. For instance, if you visualize yourself lying on a beach in the sun, you have to be there, all of you. Don't just think you are there, but feel the warmth of the sun and the texture of the sand. Hear the sound of the waves. Use all your senses. The results will be better if you choose a relaxing activity rather than a hectic one. 4. When you feel that you have stabilized this visualization, slowly open your eyes just a bit. Don't focus on the watch. Just let your gaze fall on the dial as if you are a disinterested observer of this whole affair. If you have followed the instructions properly, you may see the second hand tick in a few places, slow down, and hover for a while. If you are very successful, you'll be able to stop the second hand for quite a while. To some people, this is a shocking experience. The moment one feels shocked, the second hand accelerates and resumes its normal speed. Clearly, there is something very disturbing here. We have described several instances in which time is being somehow manipulated. I'm not saying that we have actually slowed down the movement of the clock. It is still keeping good old objective time, but we did stretch our subjective time so that we are facing a subjective situation that in turn provides an analogy to a well-known objective situation. This was first made clear in the theory of relativity, in which that was shown that two observers moving relative to each other do not agree on the rates at which their respective clocks are running. Let us try to analyze what is common to all the cases. We find that the connecting link is an altered state of consciousness. Some may claim that the last experiment has nothing to do with altered states of consciousness. In fact, some will altogether deny the existence of such a thing as consciousness. Why, then, did the watch slow down or stop altogether for a while? I suppose that the observing mind, or the observer for short, the entity that correlates and makes sense of the information submitted to it by the brain, was absent. It went off to the beach and left the hardware at home unattended. The hardware, by which I mean the sensory organs in the brain, are processing and producing the information, but the entity that correlates and makes sense of the information has left the body for a while. This is not as frivolous as it may sound. Such a hypothetical AWOL observer could have been noticed on the beach by a so-called sensitive or clairvoyant person under the right conditions. While the observer was busy correlating the information coming to him from the beach, he could not handle the information presented to him by the physical eyes gazing at the watch. From the moment the watch stopped to the moment it started moving again, the observer was out of the body. In cases in which the watch has only slowed down, the observer was split. He was partially on the beach and partially in the body, handling information at a reduced rate. In the following chapters, I intend to discuss how all these strange doings of the observer can take place. For the time being, we shall stay with the results of our experiment and try to make sense of them. In the case of the complete stopping of the watch, the eyes have become an inert camera projecting to the screen of the brain the last information they have seen before the departure of the observer. This is analogous to the little mini calculators in use today. The screen displays and holds the last information the operator has punched in. An alert reader has probably noticed by now an interesting property of this observer. He can flint about to distant places in fractions of a second. Flint? Yeah, I guess. He may leave his physical body and be off to a beach thousands of miles away and be back all within 1 or 2 seconds. In the previous chapter, we discussed the behavior of oscillators and pendulums. Let's recall what happens when a pendulum comes to one of its extreme positions. We found that between the points at which the pendulum has to come to a full stop and the point at which it started on its return trip, there is an area in which causal relationship between time and space breaks down, in which its position smears out, and infinite or nearly infinite velocities are encountered because of the uncertainty principle operating on the quantum scale of things. We know that we cannot accelerate physical objects to the velocity of light, not to speak of infinite velocities. But under the conditions we are discussing, physical matter loses its definiteness. It becomes less solid, thus making it easier for the observer to separate from it. Our bodies, as we know from Chapter 1, behave in pendulum-like fashion. It is possible that the observer, having no physical mass, could be flitting back and forth at very high velocities with each up and down movement of the body. And if this is the case, where does it go? A simple diagram will help us to put in order the previously discussed phenomena. Do not be intimidated by diagrams. The author has full understanding of most people's distaste for mathematics, graphs, etc. However, diagrams communicate better and faster than words, so just bear with it for a while. It will be over quickly. In Figure 23, our four-dimensional space-time is represented by 2 lines. The vertical direction stands for time. The horizontal direction represents space. Let us remember that space has 3 dimensions, but here they are represented by the horizontal directions only. Passage of time into the future is shown as movement upward, above the horizontal line, while all that happened in the past is shown below it. The crossing point of the horizontal and the vertical lines represents our now. It is the starting point for any event. Let us try to make use of this diagram and see how a photon, which is a particle of light, would behave on this diagram. We know that light travels at about 300,000 kilometers a second. So, starting from the now point, we mark off on the vertical line our units of time: 1, 2, 3 seconds. On the horizontal line, we mark off the distance traveled by that particle. For the first second, it has traveled 300,000 kilometers. For the next second, 600,000 kilometers. For the third second, 900,000 kilometers. From the points on the vertical line, which indicate time units, we shall now extend dotted horizontal lines, and from the points of the horizontal line, which indicate units of distance, we shall extend dotted vertical lines. These lines will cross, and through their points of intersection, we shall draw a diagonal line starting from the now point. We can extend this diagonal line below the now point into the past, and we can draw a symmetrical diagonal line also going through the now point down into the past. These two diagonals will outline two triangles touching the now with their tips. Their bases are open, of course, because we cannot put any limits on the past or the future. In fact, we can visualize the point of now as moving into the future, leaving in its wake many nows which make up our past. We can also say that the upper shaded triangle describes the activities that will occur in the future, while the bottom shaded triangle represents the events of the past. The fastest action in the physical world is naturally limited by the speed of light. Therefore, the diagonal lines representing the speed of light set the limits to the speed at which an object can travel within our physical universe. Physicists call this behavior time-like, referring to our normal space-time universe, because all action on this diagram, which occurs below the speed of light, will tend to cluster around the vertical time axis. In spite of all these apparent limitations, there are courageous physicists who are working on hypothetical particles called tachyons, which can move at speeds higher than light. The speed of tachyons starts just above the speed of light, and it ranges all the way to infinite velocities. This brings us to the other portion of our diagram. Suppose that we have a tachyon going at an almost infinite speed, which implies that it is moving practically along the horizontal space axis only. It is going so fast that it uses up almost no time. In the previous example, it took the photon 3 seconds to traverse the 900,000 kilometers as shown in the diagram. Tachyon will travel that distance in practically no time at all, so that we can plot its movement on the horizontal without regard to the vertical time axis. There is nothing to be marked off on the vertical scale, since almost no time was used for the motion of this tachyon. Suppose now that tachyon slows down at 1 million kilometers a second. This is still considerably faster than the speed of light, and the point representing the speed of the tachyon will naturally be marked off on the vertical line as shown in the diagram. However, it will appear closer to the horizontal line than it will appear closer to the horizontal than to the vertical axis. In short, all speeds that are faster than the speed of light will tend to cluster around the horizontal space axis, and therefore such behavior is called by the physicists space-like. Speeds at which space is traversed while very little time is used up will be termed space-like activity. When something moves so fast that it uses almost no time for its movement, then it moves at an almost infinite speed, and when something is going so fast, then it must be present at all places at once. We mortals could perhaps give this kind of behavior a more fitting name: omnipresence. This is a very important concept on which we shall expand later.